Tutorial sheet 2, question 7. AM double sideband receiver uses a square law demodulator. What is the maximum modulation index that may be used if the second harmonic distortion of the modulating signal produced by the demodulator is to be no more than 10% of the fundamental? Well, for this we need to recall the element from the notes relating to the square law detector. If I redraw the circuit from that, so this is what we're using. So we have some resistive load and we have some current that is flowing through this diode here, and our AM signal, our modulating signal, is the voltage that's at the input to that square law, and we're using the characteristics, the non-linear characteristics of the diode, which looks something like that, which in a functional representation can be written as some constant A times the input voltage plus another constant B times the voltage squared. And obviously A and B would be dependent on what the properties of the diode were. So if we go through the notes and look at the expansion and all that, we need to put in the mathematics for this. So we need to put in the standard form of VAM. So VAM as a function of time, as we know, is VC 1 plus M sine omega mt sine omega c of t. What we're doing is putting this equation into this circuit and expanding this. And when we do that, I'm not going to do it here, but if you can look through the notes, we get two components. We get a component which has a frequency of omega m, and that has an amplitude which is equal to B VC squared times m, and that is at the frequency of omega m. And we also get a component at 2 omega m, which has an amplitude equal to 0.25 B VC squared m squared. So what we're trying to work out here is what is the maximum index if the distortion between the second harmonic to the first harmonic can be no greater than 10%. So if we divide these two equations, in other words, we work out the second harmonic divided by the fundamental, we get m over 4 if we do that. And if we want that to be less than 10%, obviously rearranging that equation, we get m got to be less than 40% or 0.4.